So here is question number 26 everyone. XL 400 ohm, XC 300 ohm and R is 100 ohm. The peak value of current and phase difference between voltage and current is what? Now the net impedance first of all can be written R square plus XL minus XC whole square. Putting the value of R, XL and XC, we get the value of Z as 100 square plus XL, that is 400, minus XC, that is 300. So 400 minus 300, 100 square. 100 root 2 ohm is the amount of impedance. Now RMS value of voltage is given. RMS value of current can be calculated now, that is V by Z, or 200 upon 100 root 2, which comes IRMS as 2 divided by root 2. IRMS is known. Now you can calculate I naught, that is IRMS into root 2. 2 ampere comes the result. Now let's talk about the phase difference. Draw the phasor. This is R. XL is larger, XC is smaller. So if this is XL, then that will be XC and net will be XL minus XC. Draw the impedance triangle. This will be impedance Z. So this will be phase difference phi. From here tan phi we can write perpendicular upon base, that is XL minus XC divided by R, which comes 1. So phi will be 45 degree, and since XL is greater than XC, so voltage leads by pi by 4 phase difference. We lead by current by value pi by 4. Now let us go for the option. Root 2 ampere, wrong. Root 2 ampere, wrong. 2 ampere voltage leads by pi by 3, again wrong. 2 ampere voltage leads by pi by 4, correct option. So we will go with option number 4 only. So here is question number 27 everyone. The electric and magnetic field of an electromagnetic waves are in phase and parallel to each other, and also parallel to the direction of propagation of wave. In phase, parallel to each other and perpendicular to the direction of propagation of wave. So the actually question is talking about the direction of electric and magnetic field in an electromagnetic wave. And we know very well, in an electromagnetic wave, electric and magnetic field vectors are perpendicular to each other. And further perpendicular to direction of propagation of wave. So from here, now let's go for the options. In phase, parallel to each other and also parallel. No, absolutely wrong. In phase, parallel to each other, wrong. In phase and perpendicular to each other and also perpendicular to direction of propagation of wave, that seems to be true. So we will go with this option, that is option number 3. Move on to the next. So here is question number 28 everyone. A tuning fork gives 5 beats per second when sounded with an open pipe of length 20 cm vibrating in its fundamental mode. It again gives 5 beats per second if length of pipe is increased by 1 cm and it vibrates in its new fundamental mode. The frequency of tuning fork will be what? Now we know very well beat frequency N2 minus N1 will be given by N, where N is beat frequency. So from here the frequency of tuning fork is suppose N, so this N can be written either N plus 5 or you can say this N dash can be written either N plus 5 or N minus 5. Now Fundamental frequency for an open argon pipe is given by V divided by 2L. And that is, let us suppose we are taking n plus 5, where n is the frequency of tuning fork. Equation number 1. Now, if we increase the length, frequency will be decreased. This is larger frequency, this is smaller frequency. And in question, the length is increased by 1 centimeter. So, new length will be increased and therefore new frequency will be decreased. Plugging the values, we get V upon twice L plus 1 equals n minus 5. Equation number 2. Now taking the ratios, what we are going to get? 1 by 2, 2 times L plus 1 divided by 2 times L equals n plus 5 upon n minus 5. 2 cancel out. Now L plus 1 divided by L equals n plus 5 divided by n minus 5. Now putting the value of L as 20, we get 20 plus 1 divided by 20 equals n plus 5 upon n minus 5. Cross multiplying and solving, we get the value of n as 205 Hertz. So this is the frequency of tuning fork, and we can say that option number 4 is absolutely correct. We'll go with 4th option only. Now move on to the next. So here is question number 29, everyone. A small disk of mass m is released at a height small h on a circular track of radius capital R, whose part AB is sufficient friction to prevent slipping, while BC is smooth. The maximum height attained by disk on BC side will be what? Now first of all, here there will be friction, so rotation as well as translation both will occur, but here there is no friction, so there will be no rotation, only translation, means here slipping will occur. Now from A to B, suppose energy will be conserved. Total energy at A, that is mgh, must be equal to total energy at B, that is, means particle is performing rolling, means it will have translatory as well as rotatory motion. So translational kinetic energy as well as rotational kinetic energy, half mv square plus half I omega square. Putting the values, half mv square plus half moment of inertia of disk about its center of mass, mr square by 2 multiplied by omega, that is v by r, so square v square by r square. Solving gets us mgh, that is 3 by 4 mv square. Now let's calculate the value of half mv square from here, because we will need it after that. So half mv square we can write from here, that is 2 by 3 mgh. Equation number 1. Now for journey B to C, suppose particle reaches maximum somewhere here. Now the kinetic energy is getting converted into potential energy. From B it will only slide, it will not roll, it will only slide, means there is only translational kinetic energy, that is half mv square, which will be completely converted into potential energy at the highest point, that is mg h dash is the highest point, or you can say height. Half mv square 2 by 3 mgh equals mgh dash. mg gets cancel out and we get the value of h dash, that is 2h by 3. So therefore we can say that option number 1 is absolutely correct. So we will go with option number 1 only. Now move on to the next. So here is question number 30, everyone. The blocks A and B are shown in figure have masses 5 kg and 4 kg respectively. The system is released from rest. The speed of B after A has traveled a distance of 1 meter along the incline will be what? We have to take G as 10. Pulley and string are ideal and plane is smooth. There is no friction. Now first of all, let us establish the constraint relation here. Suppose tension in this string is T, then tension in this string must be 2T. Now according to constraint relation, the product of, suppose this B has traveled a distance XB upward and A has traveled a distance XA upward. So therefore we can write tension in B multiplied by distance covered by it must be equal to tension in A multiplied by distance covered by particle A. Tension in B, that is 2T XB. Tension in A, that is simply T XA. TT cancel out. We got the constant relation, that is XA equals to 2 times XB. Means whatever distance XA is moving, XB will move half of that. Or whatever distance XB is moving, XA will move twice of that. The same relation we will have for the velocities. VFA will be equal to 2 times V of B. Velocity of A will be twice velocity of B. Now let us apply the conservation of energy according to conservation of energy. The energy of this system, whole system, will be conserved, or therefore we can write total energy of system initially must be equal to total energy of system finally. Let us take this as our reference line where the potential energy is 0. So initially B has 0 potential energy, system has released from rest, only A will have the potential energy. So potential energy initially A has and kinetic energy is 0 equals. Finally both have their velocity after some time. So kinetic energy half ma Va square, kinetic energy of B half mb Vb square, and this B will cover some height, so it will acquire some potential energy Pb. Now therefore we will get the value of Pa minus Pb as half ma Va square plus half mb Vb square. Now potential energy of A, that is mass of A 5, gravity G multiplied by h, height above. See, sine 37 is the angle, so sine 37 is actually 3 by 5. If this is 1 meter, then this will be 1 cos 37 and this will be 1 sine 37. So h will be 1 into sine 37 minus for B. If potential energy for B, mass of B, that is 4, gravity, that is G, multiplied by h. From the constant relation it is clear, if XA has moved by 1 meter, then XB will move by 1 by 2 meters. So put 1 by 2 right here, which will be equal to half mass of A 5. Speed of A equals to twice speed of B, because we have to think about speed of B only. So at the place of A put 2 Vb square plus 1 by 2 into mass of B 4 Vb square. Sine 37, that is 3 by 5. Let's make one more step. 5 into G into 3 by 5 minus 4 into G into 1 by 2 equals 5 into 2 to the 4 Vb square divided by 2 plus 2 Vb square. 5 cancel out, 2 to the 4, so 3G minus 2G, that is G simply equals 5 to the 10 Vb square plus 2 Vb square, that is 12 Vb square. And after solving, we get the value of VB as under root G by 12. That is under root 10 by 12, or further it can be written VB as under root 5 by 6 meter per second is the value. So we can say that option number 3 is absolutely correct, so we will go with option number 3 only. Third option is the correct one. Now move on to the next.